One of the biggest mistakes my mathematics students tend to make is thinking they can memorize formulas and compute answers without really understanding what's going on and get the right answer all the time, but more importantly, that they think they'll actually be getting something out of their mathematics education. Well, mathematics is a way of interpreting the world, and so if you're going to learn a formula, you should understand where it came from, why it works, and hopefully another way of kind of viewing your answer and checking to see if it's right. And we're going to see in this example of slope how, without even calculating what the slope is, we should already know some characteristics of what it should be. And so let's go ahead and look at these two graphs and see what positive and negative slope mean. So in this example, I have two lines. One of them has a positive slope and one of them has a negative slope. Now, one of the things is when we read from left to right. So an easy way to remember the slope is what's happening as we travel from a point on the left to a point on the right. And we'll formalize this and see how we can kind of tie that into our definition of slope, which is, of course, the change in y over the change in x. But less formally, as we travel up this line here from one point to the other, as we go from the left to the right, you can see that we're clearly going up. So this would be a positive slope over here. And in the second example, you can see as we travel from the point on the left to the point on the right, we're clearly going down. So that would be the negative slope. Okay? But we can actually do this a little bit better if we consider the fact that the whole reason that we deal with slope the way we do is because it's easier on a graph to count from left to right and from top to bottom, or bottom to top, than it is to count diagonally. That's what an XY axis is set up for, is to count horizontally and vertically. And so if we look at this example, the first one here, we can see we're clearly traveling in the positive direction, and then again in the positive direction. Well, that would tell us that our slope would be a positive over a positive, which would of course be positive. Okay? However, we could actually start at this point here and travel in the reverse direction. In this case, we would travel in the negative direction horizontally and in the negative direction vertically. Well, as it turns out, that'll give us a negative over a negative, change in y over change in x, which we of course know is positive. Either way, we get a positive slope. Well, let's look at our other example. So in the second example, okay, if I travel down first, well, that's going to give me a negative change in y. And then to the right, that's going to give me a positive change in x. Well, then my slope is going to be a negative over a positive, which we of course know is negative. Doing the same trick as before, if I start at the rightmost point and travel up, or in the positive direction, and then to the left, or in the negative direction, well then in this case, I'm going to get that the slope is a positive over a negative, which of course would still be negative. So either way, these 2 points are going to give me a negative slope. So now that we know how to interpret whether a slope is positive or negative, we know that that's going to tell us if a relationship is going up or down, which you can imagine would be really important in any sort of real world application. In addition, on those math tests, you're going to be able to tell if you computed the slope right or wrong, because the most common mistake tends to be from kind of not knowing if it's positive or negative. And we'll learn more about that later.